so we have to find the points on this implicit equation where the tangent is horizontal. Okay, so which means we're still looking for dy over dx when that's equal to 0. Okay, so when does that happen? Okay, so we first need to differentiate this implicitly and get dy over dx. Okay, so we're gonna get, first of all, differentiate this whole power of 2, so you get 4. Chain it by the derivative of what we have inside is this. Differentiate inside, we get 2x minus 2y, chain by dy over dx. Okay, so let's expand this whole thing in. And we're doing that because we want to collect dy over dx. So first of all, you get 8x, and then you get 8y dy over dx, x squared plus y squared. On the other side, we get 50x minus 50y dy over dx. Alright, so this term and that has dy over dx. So let's bring those to the left side. So that's already on the left side, 8y. Let me write it like this. Bring it over, you get 50y. So you got to add both sides about this exact amount, and you get 50y dy over dx. Okay. And then factor out dy over dx. Alright, and then finally dy over dx. Okay, all over. That. Okay, so now we have to ask the question, when is this equal to 0? Okay, for that to equal to 0, that can only happen when the numerator, which is 50x, right, minus this whole numerator. Let me factor out x because I noticed that they have that x in common. You get this. Okay, so when that's equal to 0, the whole thing will turn into 0. So one solution is clear. It's x is equal to 0. Okay, when x is equal to 0, the whole thing will turn into 0. Okay, for when x equals to 0, if you plug it back into the original equation, okay, so let me write it here. You get 2y to the square of squared 25 minus y squared. So you get 2y to the power of 4. Bring it over, and you get plus 25 y squared. So you can factor out y squared. And the only answer for this is y is equal to 0. So at the origin, okay, the slope is 0. Okay, so let's set this part right here equal to 0, 2. Okay, then we get this. So you get x squared plus y squared is equal to 50 over 8, which is 25 over 4. Now this here represents a circle. Okay, so let's go back to the original equation. First of all, I can replace that because I have x squared plus y squared is equal to 25 over 4, so I can replace that with 25 over 4 to the power of 2. And the y squared, I can replace with 25 over 4, right, minus x squared. Okay, so let's solve for x. So we get 25 squared, which is 625 over 16, so it's going to be over 8 when it's just reduced with 2. 25x squared. Actually, let me expand inside first. You get x squared. So you get 25 2x squared. Okay, Let's divide both sides by 25, and we actually get 25 over 8. Let's add both sides by 25 over 4. Okay, and you get 75 over 8. Okay, now if you divide both sides by 2, you get x squared is equal to 75 over 16. So x is going to be a plus or a minus of root 75 over 16, which is root 25 root 3 over root 16. So it's 5 over 4 root 3. Alright, so we found two x values, 5 root 3 over 4 and minus 5 root 3 over 4. So how do you find the y value? Okay, so it has to satisfy this equation here. So y squared is equal to 25 over 4 minus x squared. So it's going to be a plus or a minus. Y is going to be a plus or a minus of 25 over 4. Now whether it's plus or minus, when I square it, it's going to become the same. So if you use just replace the x squared with 75 over 16. Okay, and you get a plus minus times by 4, so you get 100 minus 75, that's 25 over 16. So it's plus minus 5 over 4, which means we get 4 more points. So x can be this, and you get two options, 5 over 4 or minus 5 over 4. Okay, but also x can be the minus version of that. Again, 5 over 4 or minus 5 over 4. So there's 1, 2, 3, 4, and of course the origin that we found earlier.